Hello everyone. If you were here earlier, welcome back. And if you weren't, welcome. We've already met if you were here earlier, but if not, I'm Merve. I am from the data science team at LV General Insurance, and I am responsible for our academic partnerships and research. But today I'll be talking about something a bit different than my current role, which was more linked to my previous role as a lead data scientist. But before I go into any details, who is LV? Who are we? So we are a general insurance company, and we are UK's best loved insurers. We are mostly selling insurance like car, home, have a small travel book, pet insurance. And in 2020, we got bought by Allianz Group, so we're part of a wider Allianz company. But most importantly for me is obviously the data science aspect, the data aspect of it. I remember almost 4 years ago now when I made a switch from academia to industry, my colleagues, my friends were like, oh, okay, fine, insurance, a bit boring, dull. You could see it from their faces. They didn't say out loud. But in reality, insurance is a data scientist heaven because we get all sorts of different types of data and a lot of it. We get text data, free text data, image data, tabular data, you name it. So moving on to what I'm interested in, of course, is the data science team. So who are we? So the data science team was founded in LV around, I would say, 5 years ago. And I was part of it for the past 3.5 years. And since I joined, the team more than quadrupled in size. So we are, I think, currently, if I'm not mistaken, we're 55. We have 2 more new starters coming up, so I kind of lost track a bit. And apologies for repetition if you're here earlier, but we're a team of data scientists, data engineers, and data analysts, which we call data hunters. So over the course of 5 years, we have now more than 40 models that are live, impacting decisions across the business. And the way we're structured, the way we are placed within the company is we are under a team called transformation team, and we are acting as an internal consultancy. So we are basically giving support to all of the other business functions like claims, pricing, underwriting, marketing, you name it, really. And we have some open positions, adverts, so please go and check our Twitter and LinkedIn page, and if you want to connect with me, also please do so from my LinkedIn as well. So back to our 40 plus models live. So what does that mean? What do I mean by when I say we have models live? So when we build our models, we kind of deploy them as a microservice. So we basically create an API endpoint. So all the source systems across the business, for the sake of argument, let's pick claim systems, can then make a call to our model API by sending a request. That request message would include data, some data points basically, one data point at a time, which wouldn't be a surprise to you that they are the features that we use in our models. And then the model will return a response back to the source system. So in an ideal world, we'll return back some form of score and whatever you agreed on with your stakeholder. Or if it doesn't work, then you would, again, handle the error or exception in a controlled manner and return back an error message that you can easily debug and understand what went wrong. So it's all jolly good that, have a pipeline, it goes live, and you return your real-time response back. But it also means that there are quite a lot of things to consider, quite a lot of checks you need to have in place for it not to go wrong, really. And one of them is around the model input. So what happens if the input data that you're receiving from a source system actually is not what you expect? Then you probably cannot guarantee that your response is trustworthy if you ever actually get a response, or your predictions are not precise. So this is what my presentation title, data quality, means. So today in this talk, I'll be focusing on checking the input data quality that comes into our models and how to ensure that. So basically, the first question is, okay, then we need a checklist. What do we want to check? What do we need to check? So we need to ensure that the input data that's coming live to our models is in line with what we trained the model initially on. So we need to do checks like, for example, the column names, what we expect. Are we getting the data that we expect to get? The data under these columns are the same type that we were expecting. If they're numeric, for example, what are the value ranges? Are they in line with our training data? About the categories. Have we seen these categories before? Would our pre-processing pipeline be okay with those categories? Or what if you have like a new car make, for example, introduced? Would it break your model? What's going to happen? And yeah, basically, we need to decide on what checks we need. And then you kind of perform these checks on the new data point that you receive. And in our current setting, for the live models, we receive one data point at a time. So when the model gets called, there's one data point. So you can think of it as like we're passing one new row at a time to models. So that's what we need to check on. Okay, so what do we need to check? We have a list. The other question is, when do we need to perform these checks? So we have a few options there. If you remember the source system API picture, so we can either make these checks, do these checks at the source system. We can have these checks before the model gets a request, or we can have like a middle step before the request reaches our models. Or we can kind of encapsulate it in the API and do the checks before we run the pre-processing and run the models. And we chose the latter approach, just encapsulate everything and run everything in the API. So basically after that, okay, what are we checking? When are we checking? All good. And how can we check is the next step. So are there any, the natural question here is, are there any tools available before we go down the route of building our own tool to do these checks at the point that we want to perform the checks? So the answer is yes, there are some tools. And then we went through some of these tools to see if they're actually fit for purpose, fit for what we're looking for. So one of the potential solutions you might already be familiar with, if not, it's PyDQ. It's a library built on Apache Spark, and it's built for defining unit tests for data. And I bet you've heard Apache Spark before. It's mainly used for large data sets, which means that this is limited to PySpark implementations. And yes, the data sets that we're dealing with might be large, though not that large in our case, basically. But in live setting, I said we're receiving one data point at a time. So this is not actually very suitable for our single record testing. And we're not using PySpark. So it would basically require us to change a lot, basically, to implement this solution in our case. So this was a pass for us. The second solution we checked was Great Expectations. So I should say that this was our team favorite. So if you haven't seen this, if you're not using this, I would strongly recommend actually go and check it. It's a very nice library. It has an exhaustive list of data checks. It has automated Jupyter Notebook interface. It's quite easy to use. It's great, basically. But all of this comes with price, and this price is not money. So it's actually free, but it's time. So when we did checks, if I'm not mistaken, for one row of data, it was taking around like 0.3 seconds, I think, to do these checks. And quite often, we have the business requirement to return a response in sub-second. So imagine your data checks is actually taking 0.3 seconds. So then you need to do pre-processing, run pre-processing pipeline, then scoring, and then form your response message and send it back. So we thought, well, we actually need something a bit lightweight compared to Great Expectations. But it is a great tool to run checks on a batch data set. So if that's your case, I strongly recommend going and checking it. But Great Expectations was sadly a pass for us. Another solution is Marshmallow. It offers simplified object serialization, and it serializes and serializes the input message into primitive Python objects, Python data types. It provides data validation with Marshmallow schemas, and it's framework agnostic. And it is actually quite lightweight, and it kind of ticked pretty much all of the boxes that we were asking for. So, end of presentation. I'm not sure what happened. I can keep talking. So Marshmallow is actually, it addressed quite a lot of what we were looking for, thank you, and we are actually using Marshmallow. But then you can ask, okay, what's the deal with the input checker then? Isn't it what we were promised? Okay, so I go back to how our whole process works. So we're receiving an input JSON, the JSON that we're receiving from our source systems. And then we have the Marshmallow running. So that is the very, very initial check that we check the value ranges, we check the data types, and we serialize this input JSON message that is coming. And then what happens, what we do after that is something we call live data fixes. In an ideal world, you shouldn't need that. But in practice, what happens is the training data that you have sometimes does not necessarily match with your live data. Quite often it is like, it can be small things, like just a column name, for example, that you need to introduce certain checks. So this is where we are introducing the data fixes. And so then basically we need an additional input checks. There is another reason we need to perform additional checks, which is the potential discrepancy between the data requirements of the underlying database and what our models need. So I'll just take age as an example. In your source system, like 10 is a valid age, right? It's not -5. So the database might be designed to accept value 10 because it's a valid value. And if there are no additional checks in your source system, that 10 can actually get passed to your model. But of course, you shouldn't be quoting or getting any insurance when you for your 10. So that's basically the model requirement. So there might be some certain discrepancies around that. So we would want additional checks purely around the model. So hence the input checker. So we realized we were actually reusing a lot of the code, so we decided to package it up as a good practice within the team. So we created a fairly lightweight Python package. So basically what were the requirements? Just to recap, when we built the package, it's flexible. We have adaptable schemas, and we have future-proof model deployments. So what I mean by that is we have functionality added to input checker that would enable you to update the input checker object if, say, for example, you have a new car make introduced in the market, if it's not going to break your model, of course, but you can introduce it in your check, so it's not going to throw an exception, so it's quite adaptable. It's streamlined. What I mean by it is it fits our current workflow, the way we are productionizing our code and the way we're deploying our code, so it's not actually disrupting what we were doing before, but rather it's improving, and it's suitable for our current deployment pipelines. And it's quite easy to use. We have used scikit-learn's pipeline framework, so you basically fit it on your training data and transform your live data, and you can also add it as part of a scikit pipeline before your pre-processing steps as well, so it's quite easy to use. And is quite lightweight in terms of efficiency in runtime and low memory usage. So it's again ticking that box as well. So it's not adding a huge computational burden on top of doing the marshmallow checks. So just a quick toy example, no live demos. I'm using a bit of an earlier version of an input checker here, but I just wanted to still show that as an example, how you would initialize it and what you basically need to pass to it. So you can, when you're initializing, you can explicitly set what columns you want to run the input checker on. If not, it will basically use all of the columns you have. You can explicitly pass the types of the columns, what would be, categorical, what would be numerical. You can also pass date type. Or it would automatically infer the types of columns itself. And then after you initialize it, you basically fit it on your training data. So it's as easy as that. And then what happens afterwards is, so one all good input data example. When you have your new row of data, then you can transform that data point using input checker transform function. And if everything's good, if it passes all the checks, then it just returns it as is. But if it is not accepted, for example, in this case, I just send an age 10. It would just throw an exception, and the error message is again quite easy to understand. It basically said it failed the minimum value check for column age because you passed 10, which is below the minimum value that is in the training data. So this is also quite handy if you want to go and check your error logs, for example, to debug what went wrong and why your model actually did not return the score. So it's quite easy to see what went wrong and what you can improve if there's anything that we need to update. It also does check, so if you know what columns can take null values, if you don't have any pre-processing steps set up for a certain column to accept null values, it can also identify that. So there's quite a few checks. So I suggest you go and check it for yourself. The other fairly recently added functionality to input checker was on for batch processes. So as I mentioned, for live models, we receive one data point at a time, but if it's a batch, you can have, I don't know, hundreds of data points that you want to run input checker on. So what was happening before, it was basically throwing an exception and halting, terminating at the first erroneous data point. But we didn't want that. So we've added a functionality that you can choose a batch mode, you can set the flag. So what it does afterwards is basically splitting the output to two data frames. So one is the approved data points, so it will be passed separately, and the rejected data points will be split into a separate data frame, so it won't terminate the process, basically. So just to summarize why we went down this route, I hope, if you weren't convinced before, I hope you weren't, that the input data quality checks help ensure confidence in our model predictions. And in that case, there's no one-size-fits-all solution. It really does depend on what you need, how your whole process is, and then you need to then decide what tool or tools combined you need to use to perform such input data quality checks. For our case, it was Marshmallow together with Input Checker solves our problem. And the good news, hopefully, is the Input Checker is open source. So we open source it so you don't have to go through the same steps. And it is one of our currently 3 open source packages. So we're giving back to the open source community. We have 2 more packages that are open source. One is Tubular, And sadly, that's the only one with a jazzy, snazzy logo. I hope we get some nice logos for the other ones as well. But Tubular has lots of functionality for future engineering, so lots of different transformers available. And Test Aid, I would say, your lifesaver when you're writing unit tests. So please go and have a look. And if you want, please contribute. There's also instructions on how to contribute to our open source packages. But yeah, that's all from me.